Okay, so this is the first, or part one of a three-part series of brief, I hope to keep these very brief videos on data and distributions and what we mean by a distribution and what those look like and so on. So now I've measured something and I get a bunch of numbers. Each individual number is called a datum and the whole set is called data. Great. So now what? Well, let's take a specific made-up example just to make things a little more concrete. Let's suppose we've asked people their agreement with some question rated on a scale from 1, strongly disagree, to 5, strongly agree. We get some data that looks like this right here. You might be able to make some sense out of it just by looking at the raw data, but that's only because in this very simple example it's made up so that you can see what's going on in the raw data because there are so few observations. In real data, there's typically going to be hundreds to millions of observations, so you don't want to try to make sense out of it just by looking through the raw numbers. But let's try that with these data, just so we can see how the ways of summarizing and illustrating the data actually work. The first thing you might notice is that very few people said 1 or 5. Most of the people were in the middle of the scale on agreement, somewhere around a 3. Another thing that might seem so obvious it doesn't even bear comment is nevertheless very profound. Not everyone had the same level of agreement. In other words, the data are distributed along the number line, not just stacked up in one place. So another name for data is a distribution. Here we have a single variable that we measured, so this is a univariate distribution. Univariate is just a fancy word for one variable. Alright, before we move on, let's quickly review some measurement theory. Hopefully you've already watched the video on measurement theory. We actually have two variables here, right? But we only care about one of them. The other is more of a placeholder. What kind of variable is person? Pause the video and think about it if you don't know right away. And if you haven't watched the measurement video, go do that. Person is, of course, a nominal variable, meaning that all it does is refer to a single instance. It has no real value, so those numbers there could just as easily be replaced by names, random letters, or whatever. Person 6 is not twice person 3 or 2/3 of person 9, and the distance between 6 and 7 is not the same as the distance between person 2 and 3. Those concepts of ratios and differences don't make any sense for the person variable. Now what about agreement? Well, agreement is at least an ordinal variable, and most data analysts would treat it as an interval level variable. There was controversy way back in the mid-20th century among statisticians about whether this kind of rating scale could be treated as interval or not, but that's a topic for another video. For what we're about to do, we can just accept that agreement is at least ordinal. So we can make some sense of these data because this made-up set is so small, but in real data we need better ways of summarizing the information and seeing what patterns are there, if there are any patterns. One thing we can do is just count the number of times each value comes up in the data, and we call this the frequency. So let's just count the frequency of each value. So how many ones are there in the data? So now we're talking about agreement, right? We're not talking about person, just agreement. How many ones are there in agreement? Well, I'm sure you can see that there's just one. There's one. How many twos? Well, you can see that there are two values 2 there. And how many threes? Well, there's 3 threes. How many 4s are there? 2 4s. And how many 5s are there? There's just 1 5 in the whole data set. So now we have a new set of numbers, yet another distribution. And this one is called the frequency distribution, since it is a distribution of frequencies. Now in this absurd example, it's only slightly smaller than the raw data. But in real data, this can be a super handy way of seeing a pattern in the data. In the next video, we'll take the next step and make a picture of the frequency distribution, something called a frequency histogram. And in the one after that, I'll actually cover a more advanced example, something called the grouped frequency distribution. But for now, this video I think has gone on long enough, so we're going to cut it there. Frequency distributions.